The 360 on Energy and Carbon, hosted by 360 Energy. 360 Energy is a North American leader in energy and carbon reduction. Recently, we have launched the 360 Carbon Excellence Program, designed to make corporate climate change actions more effective and successful. For more information, check the link in our podcast description. Welcome back, Dave and John.
Good to be here.
And it's nice to be back as well, Lysandra.
Wow, so we haven't recorded just the three of us in a while, but I see you've learned to pause when one person responds. So that's great news. No overlapping.
I think I've been listening to our podcast and realize every friggin' time we do an overlap. So I really made a point of being cautious on that one. So hopefully this will now be our new standard.
We're learning as well, so that's great. So today we're talking about renewable energy basics, and I think this is a really important time to talk about this. We've had quite a few guests in the oil and gas industry on our podcast in the last couple weeks, and we often refer to renewable energy, but we haven't really had a full episode to talk about it. So I'm really excited to get into this episode. And to kind of start it off, of course, what is renewable energy? Can you explain the difference between renewable and non-renewable?
Yeah, I'll have a go at that. It's quite trivial, the difference. It's in the name. Often people get confused and use all sorts of different language around things. And then there is the issue about what people call renewable or not. So let's just take it simply. Renewable energy is an energy where the source of it, if you like, will not run out. So it keeps renewing itself, so we will not have a problem of exhausting the supply. Way of looking at a non-renewable, a good example of that might be something like coal, where you mine it out of the ground. As you mine it out of the ground, it's not replaced unless you're looking at a geological timescale. And I don't know that we're ever going to get, lay down more coal. So non-renewable fuels and energy are a finite source. They will run out. There is an end date to them. Renewables, we hopefully can go on and on using them.
Okay, great. So on that note, more terms that we've heard of. What is the difference between renewable energy, clean energy, and low carbon energy?
They can all be the same or not the same. So let's unpack that a little bit. There is an assumption that renewable energy is in fact a clean energy. It doesn't cause any pollution or whatever. You need to just step back a little bit from that, because some forms of renewable energy aren't without issue. So if we take, for example, let's take solar power. Say we're going to have solar PV, photovoltaic, where sun's going to fall on panels and create electricity. That, in the process, is very clean. There's not a problem with that. It's not as efficient as it could be. It's about typical solar panels are about 20% efficient. So we've got that there, but that is renewable energy. And we can say it's clean unless we get really detailed about how the panels were made. And that becomes a separate issue. We then move on to clean energy. And this is a term, should we say, that's used by, should we say the sector where there are fuels that are known to not be clean, but they are using processes to deliver them in a clean manner. So one of the ways you could be doing that was if you were generating electricity, say with natural gas, if you were capturing all of the emissions from that process, storing them or do something with them, you could say then that was a clean energy, but it wouldn't be a renewable energy because electricity is being generated from natural gas, and natural gas is finite. Low carbon, well, all of them can be low carbon. Low carbon tends to be a catch-all phrase to allow you to use fuels that are not zero carbon. One of the big low carbon fuels that's there is nuclear power. Some people are very uncomfortable, and understandably, referring to nuclear power as a renewable energy. Flip side of that, do we think that we would run out of uranium, not be able to generate nuclear power? Currently, no, we believe that we can carry on doing it. Is it clean? Well, it's very clean at point of production because you're not emitting CO2. There's just the problem of what do you do with nuclear waste? So how do you factor that in? I think where we've gone with this is that different sectors, if you like, of the energy industry have used different terminologies. So, for example, we're talking renewable energy, we talk renewable, we don't often talk about renewable electricity, but we talk about green electricity. And then we get the issue when somebody's calling it green, how is it green? Is it supplied by windmills or something like that? Or is it that the supplier is buying carbon offsets or doing something else to call it green? So defining what these things are is can be complicated. It's great when everybody's having the conversation is using the same language. It really does help, but often they're not.
John, as you're talking, because when we're both talking to clients, there's continual confusion and misunderstanding of what these are, and that certainly is impactful, because if you're trying to plan what you want to do and how you're going to do it to reduce your carbon emissions, it would be nice. So I'm going to suggest that for what we'll do in the future is we'll put definitions and make them available on our website so people can refer to these down the road if they want to have some clarity. I think that would be helpful for the marketplace that they could refer to as we go forward.
Yeah. And I'm not criticizing some of our guests that we've had who've talked about clean energy, but the clean energy is actually, in some ways, is a response from the fossil fuel side of the industry to try to deal with the issue of climate change. I know there was derision many years back when there was a discussion, there was the concept of clean coal being introduced. And somebody, how can you make coal clean? And again, the whole point of that was having a serious investment in plant that you captured all of the emissions.
Yeah, it is really interesting to see that because coal, as we know, is phased out in some countries, but still a major energy source in other countries. So in that case, I guess we would prefer them to have clean energy coal rather than just strictly coal. So I
Yes.
do think it gets a bit interesting there.
Can I just add a little anecdote to this? Because we've mentioned coal. I don't know if it's quite the same in North America, but we have a lot of heritage railway lines in this country that are operated by amateurs, tourist lines, but they operate with classic vintage steam engines. Operators of these trains are now having a problem sourcing the appropriate coal because of the dialing back of the coal markets in the world. So it's quite interesting what's happened. Coal was the ultimate dirty fuel as opposed to clean fuel. And now we're getting to the point where in certain parts of the world there's shortage. But Lysandra, you're absolutely right. As we move out towards the Far East, there is, and sort of Australia as well, that part of the world, coal is still a major element of the fuel mix. And as we say, as it is, it's not clean and it's not renewable. But if that's what keeps your economy going, it's difficult to say that you shouldn't use it, isn't it?
So I'll pick up on that, John, because Alberta, half the generation was coal-based. And now they're making every effort they can to make the transition from coal to they're using natural gas and renewable fuel. And coal is a big industry. There's a lot of mining that goes on in Alberta. So the transition is going on everywhere. And I think a lot of times people think they just flip a switch and then it's done. And it takes time to make that transition. There's a lot of things that have to be, you have to have infrastructure in place. You have to allow you to make that transition and move the skill set towards that as well. So it's not something that can move as quickly as people think it can move. That's something we need to make sure our listeners understand that as well.
I think, Dave, you used a word multiple times there that's a really important word, and it's transition. So right, there isn't a simple binary switch that we can go fossil fuel, renewable fuel, and everything switched over. We've got to have a transition. And I think that's one of the reasons why the term low carbon was introduced, because a good example of how low carbon makes sense, if you move your electricity generation from coal or heavy oil over to natural gas, it becomes a lower carbon electricity. So you're looking at a change there. Not all electricity is the same carbon content, and even within a jurisdiction, let alone within different jurisdictions. So, we had the Carbon Trust formed in this country, and part of its reason was to help the country in its transition to a low carbon economy. I think that's the journey that we all need to be on if we're going to avoid, should we say, catastrophic climate change, which I still think people don't get the full idea of what catastrophic climate change might be. I'm not saying it's going to be catastrophic, but the potential for catastrophic climate change is there. That's what the body of science tells us.
Yeah, I think all three of us are definitely on the same page in the sense that a transition to a clean future requires the oil and gas industry during that transitional period. And I'm kind of curious, you both mentioned Australia, Alberta. These are places that really depend on dirty fuel as part of their economy. So just thinking that way and mentioning clean energy, how long do you think places like that could use the clean energy mentality, so things like carbon capture and storage and carbon offsets, before they actually really need to stop with those dirty fuels?
That's an interesting question. For those people who are listening and not seeing this, you did put air quotes around.
I did. I did, yes.
Just in case anybody's concerned with that. I think that's a really interesting one. I think a lot of it's going to come in at some level through, the ESG, environment, social and governance, that large corporations are thinking about. But and I reckon Dave's going to completely agree with what I'm going to say now, but I'm taking a chance on it. They will continue all the time. The price signals of that say that it's a way to go. It needs to become one of those things where it would cost you more to use coal or a cleaned up dirty fuel than it would be to use a renewable fuel. When that starts to happen, then why would anybody do it? Assuming that there's enough energy supply available.
Yeah, you're right, John. I'm in total agreement with you. If someone doesn't actually understand the impact to their bottom line because they're busy doing other stuff, they're not going to change. But if it impacts their bottom line, then they're going to start changing. Now, when I say that, bottom line can be impacted not only by your operating costs, but it also could be by your clients demanding that you do that. And if you don't do it, then they're not going to buy your product. That could impact your bottom line too. So it's what we see, and I see between yourself and us in Canada here, is that is happening on both sides. Maybe the pricing signal, there's some fine tuning that there's still work to be done there for sure.
Oh, for sure, yeah. But I think as well, I think there can be things occur that we're not even thinking about. For example, the conflict, the invasion of Ukraine has made some issues over certainly oil and gas, and it's making Germany and a few other places think about what they can do. We've seen the response of the US talking about LNG exports to Germany, and then immediately environmentalists throwing their hands up in horror saying, that's just going to perpetuate fossil fuels. But we come back to the point, if 40% of your energy demand is being met by a fossil fuel, you cannot switch that overnight. Again, you've got to transition.
And for our listeners, when we talk about fossil fuels, it's not just heating your home. There's manufacturing locations that people work in that are dependent on natural gas, possibly for feedstock or for heating a furnace. So it takes time. And come back into your question, Sandra, like this whole transition, I think like if we talk about carbon capture storage, which we talked about earlier, we talk about hydrogen, this is going to take, 10 years to start coming into the market and maturing in some fashion. So it's going to take time. And for that reason, things, as much as we would like, and there's a need, and there is a need, just I want to be clear to all our listeners, we understand the need, but some things can't happen that quickly because it's just the infrastructure's not there, to be fair.
Yeah.
So it seems like from both of you, what I'm seeing is the transition from fossil fuels to a more renewable energy or low carbon energy would be market pricing, would be demand from your supplier, things like that. and also maybe government regulation, things like
Yes.
that. Okay.
Yes, for sure. Like I never mentioned that, but for sure government plays a role in this. But I think the marketplace will move quicker than government on this because they have demands by clients and stuff. So yeah, all three play a very important role for sure.
Yeah, it gets really complicated when you look at these situations because I don't think every place won't be the same. You know, the transition in Alberta is not going to be at the same time as the transition in Australia, and the transition won't look the same either. And that's because, you know, Alberta has neighboring provinces that maybe could help out, or maybe it'll have more funding quickly. So when we get to those hypothetical questions, I always find it interesting because I think everyone has a different perspective on that.
Off topic, but we've talked about this before. Alberta, Texas, which are predominantly what deemed as oil and gas, they're kind of leading the pack on renewable energy in the marketplace, which is kind of interesting how that's now. Lysandra and I have talked about this. This is a function of geographically where they're located and the landscape that they have available to them. But it is interesting, like those two markets that are dominant fossil fuel based, they're perhaps more advanced than other jurisdictions that aren't dependent on fossil fuels and actually creating electrical generation through renewables. It is interesting what's materializing there.
Yeah, one argument can be on that, and I can remember I worked with an NGO looking at a company, and the question was, why are you working with that really dirty company? You know, and the answer was, well, because the dirty ones are the ones that have got to clean up first. They're the ones who are getting more pressure. There's more obvious. If you're in a jurisdiction where you say you're below average on carbon emissions for your electricity, say, there may be less, if you like, pressure on the system to do something about it because you're not standing out as one of the air quotes dirty generators.
Yeah, that's the thing. When we're using these dirty and clean references, I think it's just for simplicity's sake. I mean, we can sit here and be really technical and name all these fuels and things like that, but it's just not how this conversation will go. So I do want to clarify that for our listeners. We do throw around some air quotes here and there if you're not watching the video version. So, next question. What are the
Yes.
common types of renewable energy? You mentioned solar already, but I know there's a few more, and we've had some guests on this podcast with
Yeah.
other types of renewable energy as well.
I thought I'd limit it to a group. Solar is the first one, and there's two forms. There's two major forms of solar. There would be solar PV, which is where we're converting the sun into electricity through solar panels. There's solar thermal, where we will have a heat collector and we're using the heat of the sun to warm up the fluid. There's also, in building design, there's passive solar, whereby you're allowing solar radiation to come into the building to provide heat rather than it being through a medium. As far as we know, solar power is totally renewable. I believe the figure is if the sun goes out, we've 8 minutes before we know about it down here on Earth. And then things have gone really bad if that happens. So that's a major source. A number of reporters tell us that there is more than enough solar power to power the world as we see it. The only problem is it's in the wrong places. You know, if we cover the Sahara Desert with solar panels, it might collect a hell of a lot of energy, but then you've got the problem of transporting it. And I think that is the other thing about energy. It's not just getting it, it's getting it and having it in the right place. So that's solar. The next one on the list is wind, and there are a number of options there. The two major options, certainly with a European perspective, are onshore and offshore. Now, offshore works really well because you don't have things in the way of your wind turbines. Funnily enough, you use some of the technologies of oil that have been used for putting platforms and things together. But you can do it on quite a large scale. You have less planning issues with it. Onshore wind becomes a little more complicated because of geography. I don't know about in North America, but certainly in parts of more densely populated parts of Europe, you get objections from some people that they don't want windmills in sight or wind turbines. So you've got that. You then have both the problem with solar and wind of intermittency. and that is they aren't there all the time. And that is a big difference between these renewable energies and, shall we say, fossil fuels, where fossil fuels we have a lot more dependence. So when we're talking about renewable, we now have to really couple it with energy storage, because if we've got energy storage, we then collect at one time of the day and then use it at another time. A very simple approach would be having solar PV on your house, having LED lighting inside the house, and having batteries. So you would collect solar power during the day, convert to electricity, power your lights at night. We then, and I think there's one where the knowledge of this side of the water switches to your side of the water, there's hydro. Now, there are some people who are not fans of hydro because of its broader environmental impact. Certainly new hydro, because you end up flooding areas. There's a whole range of, should we say, environmental impact issues. But then there's also small-scale hydro, low head hydro. You can get hydro power from a very small generator with only a few meters of head. It goes back to using the technology that drove water mills before the Industrial Revolution. One of the problems that you've got with hydro is it should be long-term renewable, but you might have problems if there's changes in weather patterns. We have seen, I certainly know, Dave, you might recall on this, I think there was a problem in Chile, wasn't there, a few years ago, when there was the reservoirs were running dry.
That's correct. That's correct. And certainly climate change is a factor. You just named it. I know we've worked with University of Windsor, and they were studying the impact of temperature and how it relates to hydro generation. And so that actually hasn't even been an issue here in Ontario, where if the water levels are too low, that impacts the amount of or length of generation they can do. So it's something that we can't take for granted, for sure, John.
No. So we've got risk with that. And then the last big group worthy of mention is biomass. Now, biomass is, in simple terms, it's taking a plant or something that's grown and using it as fuel. Firewood is the oldest form of biomass that we've got. Problem with it is, for it to be perfectly, shall we say, carbon neutral, you've got to replace the trees that you burn or the stock that you burn. And so we've got a range of things from, there are various energy products, elephant grass is one of them, right the way through to forestry waste and things like that. There is an issue there, because I could refer you to a reporter who would say that biomass is renewable, but it's not clean. And there is quite an issue with the particulate matter from the combustion of wood. And in fact, in this country, they reckon now that we have more problem with particulates from people wood burning than we necessarily do from traffic, because we've put cleanup on the exhausts of cars. So, solutions aren't always as straightforward as they are. I'm not going to include nuclear or any of the other things in that sort of basket of renewables. Although nuclear power, I'm going to come back to it, one of its biggest benefits for us is, whilst it's being produced, it's CO2 free, and so, you can have a 97% availability on a nuclear power plant, which is very much more difficult to achieve on any of those other forms.
John, where would you place geothermal?
That's a really good point. I've probably overlooked it in that listing there. Yeah, geothermal, or as some people like to call it, I love the expression, hot rocks. What this is based on, it's based on the fact that if you go down far enough into the earth, it gets warmer, or if nothing else, certainly a certain distance down, you get a stable temperature. Now, there's two ways actually that you could look at this. I didn't include it because it's a little bit more technical in some ways, but one of the simplest ways of doing it is using a heat pump. So you use a heat pump, and you basically, in silly terms, you're trying to cool down the earth. And in doing so, you're rejecting heat, which you're using as heat. That's one format. Of course, the other format is going far enough down that you contact, heat, and then you take a thermal fluid down, and you get heat transfer with that and get yourself heating in that way. In this country, we certainly are seeing quite a push on heat pump technology. I suppose why I didn't initially include it, you put a heat pump on and you say, is this renewable? Well, I think the heat pump has to be running off renewable electricity.
Fair enough.
Otherwise, what we're getting is low carbon energy
Yes.
because we're taking the electricity and we're only using about a fifth of what we would for heating if we're using a heat pump. So
That's a good, really good point.
we're reducing the carbon impact of the electricity for heating to 20% of what it would be. But yeah, good call. I should have included it. I didn't scribble it down.
Yeah, the part where, all these renewables, most of these renewables, things like, PV and wind turbines, require so much more equipment or like things to be built that I think that oftentimes that part is very much overlooked. Like you can have thousands of solar panels, but how are you recycling them after? How did you build them? What was that electricity grid using to generate the electricity that was used to build these things? And I think you kind of get in a tricky situation, and it comes back to the life cycle analysis. Like from the beginning of the solar panel to the end of the solar panel, what are the carbon emissions? And I see that that's a typical rebuttal from people in the oil and gas industry that aren't open to the idea of a renewable future. I typically find they say, okay, well, how much carbon emissions was with the building of that solar and how much with the decommissioning of it? And I think it's interesting because when you look at the oil and gas industry, we've built equipment to use natural fuels, right? But now we have, for solar and wind, we have a natural environment and we're building equipment to use that. So it is a bit of a different perspective. And I do always find those debates really interesting.
Can I just say, you're absolutely right about life cycle. It's why a number of times I've talked about in use. So, for example, on nuclear power, in use, building a nuclear power station is a big thing. But there was a study done a good few years ago. Do you remember when the car, that if you were a trendy environmentalist, you drove a Toyota Prius? That was the car. And somebody did a life cycle study, environmental life cycle study on a Toyota Prius versus a basic Jeep. And the way they worked the figures, they went that the Jeep was a better life cycle option than the Prius. And part of that was because of all the battery technology and everything else that was involved in the Prius, versus you haven't got that with your standard Jeep. A lot of your standard Jeep at the end of life is recyclable easy. But I will make a point here for our listeners. If you're looking at life cycle analyses, cut to the end of the analysis, have a look at who sponsored it, because so
It's a
often
key piece.
it's a key piece. Yes, if it was, that was actually by, it was not by Toyota. Let's put it that way. I'm not saying anything other than it was a Jeep, but the study was not conducted on behalf of Toyota.
That's a great example. I also think it's funny because, I'm sure lots of people do not know about that study and still refer to the Toyota Prius as the better option. So sometimes I find it's hard to kind of change society's minds once they've heard that initial thing.
Yeah.
Like, for instance, lots of people think pipelines are a horrible thing. They don't really understand why pipelines are being used. So anytime a pipeline's built, it's negative from the public because they think we're doing something that's not environmentally friendly. So it's so interesting because once something's said, sometimes I feel like no one forgets it and no one is open to listening to the other discoveries that follow.
Yeah, true.
All right, next question. So if renewable energy is better for the environment, why hasn't it fully replaced non-renewables? And maybe it's not better for the environment like we just said. Maybe the life cycle analysis turns out that it's not.
Okay, I'm going to go for a really simple answer.
Mm-hmm.
It's down to cost, because traditionally, although it is changing now, but if we go back 10 years or so, renewable energy per kilowatt hour was more expensive. That is beginning to change. So we've got that. The other one is really quite simply a lack of capacity and infrastructure. And I think they're the two things that have stopped us being, should we say, 100% renewable globe.
John, just for our listeners, because I know what you're saying, can you give a little more detail on the lack of infrastructure, why that impacts? Give examples of how that
Okay,
impacts
I'll
renewable.
give us I'll give a simplistic example to start with, and then I'm sure Dave you can join in.
Yes.
Traditionally, when we built a power station, we would build a large power station in an area maybe reasonably close to a large load, but not necessarily within it. So you would not want to build a large power station in the middle of Toronto, although the Russians did in St. Petersburg. But there you go, completely different approach to things. But you would have had that, and then you would have had all your grid radiating out from that to its points of use. When we start talking renewable, we have to look at what we call distributed generation. And that is that the generation can occur at all points around the system. And I've dealt with clients who've had the opportunity, for example, to put up a wind turbine, but then found they couldn't get the connection to the grid at suitable scale to feed into the grid. So it's that's one example of the kind of problem that we've got. I then think we touch on what I said earlier. We need grid level storage capacity, don't we? Because we should we be expecting every person to have storage within their own house? Well, actually, they're beginning to, because they're plugging in their electric car. And as we know, and I don't know if our listeners know, there is an option of taking power from your electric car into the grid or into other use. Early days yet, but it can be used as a load device. But I think it's that our distribution grids, certainly on electricity, were not designed with renewables and distributed generation in mind. They were designed with a small number of very large generating nodes within the system.
Yes, and I'll add to what you said, John. Just certainly it was set up exactly that way, where their large generation were going to send out power to the market. It wasn't set up to have these different loads to send power into the grid. It was from the main area, not to all these localized areas to send it. The grid was not designed or set up for that reason. So now the grid and regulations, by the way, policies have to change to allow that. And there's time, there's costs, there's things that need to be studied because it wasn't set up that way. So I think it's a really important point, because most people think, oh, I'm going to put these solar panels on my house, and that you may not be able to do that because the grid may not allow you to put that power on the grid, because they don't have the infrastructure, the transformer capacity or the wires to accept that into the grid. So I think it's a big point for our listeners to know.
I also want to add, I think another big reason why renewable energy hasn't replaced non-renewables is things like PV, so solar, and wind turbines rely on solar, like actual sun and wind. So if you don't have sun and you don't have wind, you don't have power. And if you don't have power, you can't operate, your workplace, or you can't operate anything in your home because there's no source of energy for that.
Yeah, and that's what we touched on earlier with intermittency. And what we're saying is one solution to that is storage. And again, we then start going back, where's the storage in the grid, etc. I mean, I don't know if it's the same here. The economics of having solar panels on your home here, it's about 8-9 year payback. One of the advantages, of course, that people miss is but you have fixed arguably your electricity cost on that for the next 8 or 9 years. No problem there. If you then say, oh well, I've got to introduce storage technology, then you're extending your payback. I also think familiarity and ease, perhaps we should add to it, because at the moment, if you were building a house or a factory, just to connect into natural gas and electricity, it's simple. It's what you do, and everything is geared up for it that way. To actually have on-site generation, am I in the generation business, or I'm in the business of making tin cans?
On that note, John, what are some challenges with renewables? Now, we touched on a few already, and I think we have definitely mentioned some benefits as well, but focusing on why that transition is a bit more difficult, what would you say are the biggest challenges?
Okay, I would have liked to have said that public opinion was not an
Mm.
issue, because it's almost, a statement of the obvious that renewable energy is better because we're not going to run out of it, And if it's the right renewable energy, we're not creating pollution, damaging the environment. But you touched on one thing when you talked about pipelines, when people come up against that. Well, if we're going to make infrastructure changes, people may object to that. People object to wind farms. If they're in a jurisdiction where you may be in close proximity, people object. Although in Belgium, out of interest, if you go to the city of Bruges, they actually have wind turbines in the city. And so it depends on, shall we say, the particular population of how they are. So there is, that's one of the challenges is the public perception of renewables, so that you don't get objections. Whilst we're on that, I will tell you a little story. I can't remember where it was. It was in the US, and they were having objections to building a large wind farm. They completely eliminated the objections by turning around to the local population and saying, if we build the wind farm, we will supply you with free electricity from the wind farm. And suddenly the objections disappeared, public perception. So that's one thing. I think there are some technology issues. For example, can we improve battery technology? Can we improve solar collector technology? I think we're making inroads on the efficiency of wind turbines, but again, all of that, could we make step changes to the technologies? That would be good. We've touched on, and we've got to come back to it, is infrastructure. Got to have an infrastructure that positively supports renewable energy. We've then got to have governments putting the right kind of regulation and legislation that allows and encourages it. And for Dave, he always will come back to this, and he's absolutely right, is getting the price point right. Because if I turn around to you and say, you can have air quotes dirty electricity or air quotes clean electricity, and I'll give you the clean electricity 10% cheaper than the dirty, you're not going to sign up for dirty. You're going to go for it. So price will be an important driver there. I think the other thing is that the renewable energy field, unlike, shall we say, oil and gas, in oil and gas, we have a relatively small number of large global players who can bring the industry together and make things happen. It's not quite the same with renewables. There's lots more individual players. There's always the possibility. Electric vehicles are a good example of it. How many different charging systems do we have at the moment? So how do we get round issues like that? But that's going to be the same with any new emerging technology and market. So I think all of those problems are solvable if there's a will. Technology problems, I think I will say the biggest one of them is getting battery storage that's highly efficient, small on size, and with minimal environmental impact. We need something that uses very basic materials that we could store energy with. I think in one of our previous podcasts, we talked about using compressed air as a means of storing energy and other things like that. But we know at the moment that lithium battery technology and other things like that, they come with an environmental payload that we need to consider.
You worded something, and I hadn't thought of it that way, but fossil fuels have two kind of big markets that they play. There's the market for the fuel prices, and then there's a market for the electricity. But then when you're looking at renewables, it's really only the electricity market that you're dealing with. You're not paying for the input fuel or anything like that. And I don't think I hadn't thought of that way this whole episode.
Yeah, if you're talking solar and wind, you don't have to buy anything in.
Yeah.
It comes for free. And as we say, the price tag, air quotes, on it being free is its intermittency. Now, there are circumstances, and they've been recorded, where people go, oh, wind turbines aren't turning, the sun's not shining. And I think I will go back to a comment that was made in one of our earlier podcasts about we don't want silver bullets, we want silver buckshot. And I think when it comes back to energy supply, what we haven't talked much about is security of supply. And if we want security of supply, we're going to have a blended supply.
Great points, John. So to conclude off this episode, it was very informative. What is the biggest takeaway for our listeners?
Sure, I'll take a stab at it. I think evident of this length of podcast, because we thought it was only going to be 15 minutes or 20. It's an up and coming. Renewables is the future, to be clear. There's a lot of knowledge that has to be understood by the clients prior to them jumping into this. There's not one fix. I think John said it at the end that it's going to take a number of different things to consider and be mindful of for whether it's electrical generation or heating. But the more knowledge people get, I would encourage them, the better they understand the technology, the marketplace, the pricing signals, things of that nature, the better. And the last thing I want to say, clients need to really understand how they use energy before they figure out what type of generation they want to buy or use. And that's not very often understood by most clients. They just rely on someone, I'm going to put solar panels up and I'm done. No, it has to match their usage or come close to their usage. So I'll just throw that in for that as well.
Okay, my biggest takeaway is something that we haven't discussed, but you were nearly touching on it there, Dave. The cleanest, greenest kilowatt hour of energy is the one we don't use.
Well done, John. Touche.
Yeah, I don't think I can say anything after that one. That's a great note to end off on. Well, thank you for your time today, Dave and John.
It's been a pleasure.
Thanks,
I'm glad we were able to keep it so short.
Talk to you next week. That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn posts. See you next week.